So we are starting.
Just a second. We are online.
So good evening. I start to share my slides. So good evening, welcome back to the genealogy season of the Core Enaction series. As usual, I would like to start with a brief introduction to our session. First of all, by recapitulating what was until now our co-exploration of the genealogical path towards Enaction, a genealogical path that was structured in 4 sessions until now. The first session was an overview of this genealogical path that we propose to interpret as the evolution of a research tradition, the tradition of experimental epistemology founded by Warren McCulloch in the context of cybernetics. Then we had 2 sessions dedicated to co-exploration of the cybernetics origins of Enaction through 2 lectures, one by Professor Bruno Clark and one by Professor Juan Carlos Letelier, dedicated to the foundation of the tradition of experimental epistemology through a focus on the work of McCulloch and Pitts, and then the evolution of this tradition in the work of Heinz von Förster in the context of second-order cybernetics. And during the last session number 4, we had a lecture by Professor Tom Zinke, through which we inaugurating the exploration of the autopoietic path of the genealogical, the genealogy of Core Enaction. During this lecture, Professor Tom Zinke introduced the concept of autopoiesis, which he explored through some of its different interpretations and through related views of life, both in the genealogy, the philosophical genealogy of autopoiesis and its affiliations within the fields, mainly within the fields of philosophy and philosophy of biology, or theoretical biology, but also in the fields of the synthetic modeling of life and cognition and the cognitive sciences. And this evening we have, for session number 5, a second lecture by Professor Juan Carlos Letelier, which will help us to continue our co-exploration of the autopoietic segment of the genealogy of Enaction, our genealogy of Enaction. Indeed, Professor Juan Carlos Letelier already in his first lecture offered us a short introduction to autopoiesis, because he proposed to us a sort of a cybernetic genealogy of the notion of structural coupling, a notion which is central in the theory of autopoiesis. And today we'll focus on autopoiesis by deepening this exploration of the notion of structural coupling, a notion that is central in the autopoietic cognitive biology, because Maturana and Varela developed around this notion their hypothesis of a deep continuity between life and cognition. Indeed, the notion of structural coupling is describing the interaction between the autopoietic system, that is the living system, is seen as an autonomous system, a system characterized by producing itself by itself. This notion describes the interaction of the autonomous system, the autopoietic system, with its environment and other systems in its environment, in terms of symmetrical dynamics of reciprocal perturbations, as the systems are characterized as operationally independent from each other, so they perturbate each other with their dynamics, and endogenous compensation realized as activities of self-regulation through which these systems react to the perturbation of the other system to maintain their organization. And Maturana and Varela elaborated this notion by describing the structural coupling as a dynamic coupling in the context of which the autopoietic system maintains its organization in a continuously changing environment by associating schemes of endogenous self-regulation, so endogenous schemes of self-regulation, to the perturbations, the environmental perturbations it perceives as alterations in its dynamic of self-production. And so they interpreted this dynamic coupling as a cognitive coupling by interpreting this activity of association of schemes of self-regulation to environmental perturbations as an activity of generation of meanings. The idea is that the autopoietic systems generates meanings in terms of effective schemes of self-regulation, schemes that allow the system to maintain its organization in the environmental condition to the perturbation it perceives. And in this way, through the interaction with the environment, it constructs a meaningful world on the basis of a perturbative background. This way, through the notion of structural coupling, Maturana and Varela propose a concept of biological cognition that constitutes a radical alternative to the notion of cognition proposed in the context of computationalist or classical cognitive science, in which, on the basis of the metaphor of the computer and the thematizations of the interaction of between cognitive systems and their environments in terms of input-output interaction, the idea of cognition that is presented is the idea of more or less neutral representation of an independent world. So based on the notion of structural coupling, Maturana and Varela would propose their idea that cognition is effective action, and first of all, the action of producing itself by itself, that is exercised by the autopoietic system in interaction with its environment. So an action that is always a distributed action, a co-action that is expressed through the interaction with the environment, enabling a living being to continue its existence in a definite environment as it brings forth a world. So this evening, through an overview of the theory of autopoiesis centered on the notion of structural coupling, Juan Carlos Letelier will touch different aspects of the theory, that is the core problem, which interprets as the problem of understanding metabolism and its stability. He will consider relationship between the theory of autopoiesis and other views of life, and mainly Robert Rosen's ideas of life, but also metaphorical uses of the notion of autopoiesis that are uses that are ranging from the field of law to the field of architecture and so on. And then we'll propose to us a focus on language. But mainly what we are expecting from his lecture is an exercise of application of the notion of structural coupling, that is an exercise of co-construction of an object that he promised to us we promised to us in the last lectures, in the last sessions. So without further ado, I leave you the stage, Juan Carlos. Thank you very much for being here with us. I stop sharing.
Perfect. I am here. Thank you very much for inviting me today again. Today will be a very special class, and you will require to really pay attention. You're going to see something that you really need to pay attention, and I need the collaboration from you. Yeah? And remember that human beings, we are collaborative monkeys. The thing is we are collaborative monkeys, and we love to collaborate. Also, we love gossip. Yeah? Because we are monkeys, essentially, then you need to pay attention, because I am going to do the class, but things are going to happen. And I will try to fulfill my promise to build a relational object today. Yeah? This has never been done in the history of the galaxy. You need to understand that, at least as far as I know. Yeah? Then it's a unique phenomenon. Then how many people we have? 27, perfect. 27 participants. Then first I'm going to begin the class. Let me share my screen with you. Yeah, as usually, everything, when you want to do something, you find some little problem. Yeah. Then I'm going to make first a survey of the theory of autopoiesis as we see it from here, from our lab in Chile. And please, if you have some very important question, I don't mind to be interrupted. First, we think from our perspective here that the theory of autopoiesis, you know, the concept, is in reality two different but related conceptual corpus. One is the theory of autopoietic systems, and the other is the notion of structural coupling. They are not exactly the same, and here we make a difference, because they touch different aspects of biology. And remember, the theory essentially was born on 50 years ago. Next year will be 50 years. Was born 50 years ago in the Department of Biology in the University of Chile. Then some questions that we would like to have an answer, and we don't have an answer, is we would like to describe an autopoietic system with precision. You know, it's impossible. You ask, you know, which is the autopoietic organization of my cat, and it's impossible to answer this question. Also, it's impossible to answer the question, what is the autopoietic organization of a bacteria? No, it's impossible. You know, I used to torture Maturana asking him this question as very often. But we not only we cannot describe them, but we cannot explain their stability and robustness. To show you an example, every single bacteria, they have a lineage that connects the bacteria today to the origin of living systems more or less 4,000 million years ago. And during this huge lineage, that is longer, by the way, that many lifetime of massive stars, you know, a massive star, a star with 10 times the mass of the sun, they only last 400 million years. Then in some sense, lineages of living systems are quite, you know, are objects that are really tough in the universe because they last quite longer, quite long. Also, and then we don't know, that question of how to treat stability and robustness is totally impossible to understand for us. Fu. Then also we agree that an autopoietic system is not only a system of interconnected processes, but must be a system that acts on the universe, you know, on the medium, on its medium. And then you cannot uncouple the problem of metabolic self-fabrication from the problem of action. Yeah? And then this is why autonomy is a very, very, very important concept in the theory of living systems, and particularly in the theory of autopoiesis. Then these are aspects that we know that they are important, but after half a century, we don't know how to treat them well in the theory of autopoiesis. To make a quick summary, you must know that an autopoietic system is a system that fulfills two conditions. The first condition is this condition of circular organization of the metabolism, in the sense that the processes, you know, here, the arrows have the processes, they make components, the blue boxes, and the blue box are fundamental to produce other arrows, and these other arrows essentially are necessary to produce the components of the first process in the first place. Then this is the first property of autopoietic systems. And Maturana and Varela posited in the book of the Máquinas y Seres Vivos in 1973, they posited that this was the core property of living systems. Not that they had DNA or they had a nervous system or they had digestion, no, or the reproduction. The fundamental property of all living systems was this circular organization of metabolism, and also this self-encapsulation, because the metabolism, they produce all the components and processes necessary to encapsulate themselves from the environment. This is why we use this this cartoon, you know, this circle with an arrow to mimic the Ouroboros, you know, the snake that eats itself. This is the representation of autopoietic system. Then the real reality, I work in these things, you know, I have published many papers, and then I'm going to be honest with you today. Yeah? We have very few advances in the fundamental questions of the origin, stability, and evolvability of autopoietic networks. You know, an autopoietic system, as you see here at the left, you know, an autopoietic system is this gas, this gas, Fu, this gas of processes that are encapsulated. Then this gas of processes is really an amazing feature of the universe, because it is composed of thousands of coupled processes, and each one is very complex. They have nonlinear kinetics, and they intermodulate their efficiency. You know, they are not independent from each other in the network. Then the fundamental question is how such a system could be stable. And to give you a concrete example, Escherichia coli, the most studied bacteria from biology, has 1,600 metabolic reactions. This means the reactions that transform one molecule into another, but they have 3,000 signaling reactions that are the reactions. These are the reactions that are the regulatory reactions in the metabolism, the reactions that modulate the efficiency of enzymes. Then the amount of regulatory reactions is extremely dense. Yeah? And all of this exists with more or less 1,200 metabolites, you know, small molecules like glucose, tryptophan, pyruvate, you know. Then which principles can we use to understand stability? You know, how such a system is stable is a mystery today, 50 years ago, and if we don't put a lot of energy, it will be continuing to be a mystery 50 years in the future. No. Now, please don't get despondent with my talk today, because here I'm going to tell you a great secret, is that really the theory of the autopoietic system, we don't have a proper theory yet. Myself, I am very optimistic, but really, we don't have a fundamental theory yet. I need to point you that quantum mechanics in a period of 30 years was built three times with different venues of approach. You know, quantum mechanics really was quite an amazing story, because they built what is called the old quantum mechanics due to Bohr and Sommerfeld. Then you have the quantum mechanics built with matrices with Heisenberg, and finally the working one quantum mechanics using the equation of Schrödinger by Schrödinger. Then the physicists at that time, they were able to produce an edifice of theorems and ideas in 30 years, three times. And we don't have nothing similar to that. Then people have tried. By example, Varela tried to use indicational calculus, and he wrote a book called The Principles of Biological Autonomy. But this, it's like everything else has been a petition, you know. It was impossible to expand the ideas of Spencer Brown, of the laws of form, into a working view of metabolism or a working view of the interaction of an organism and its medium. You know? Now, it seems to be that the indicational calculus is a dead end. Also, people have tried to use the normal tools of physicists, like the models based on ordinary differential equations, but it's impossible to understand with ordinary differential equations systems that have thousands of variables. Yeah. What are you going to explain? No. Yeah. Cybernetical principles. People have tried to use cybernetical principles, but my point is, do they really exist? You know, which are the cybernetical principles? You know, who remembers in this audience the law of the requisite variety? This was a law of cybernetics, you know, due to Ashby. And for the people who don't know the law, I put it there, the law for a system to be stable, the number of states that its control mechanism is capable of attending, its variety, must be greater or equal to the number of states in the system being controlled. As you can be, the law of requisite variety is a law about stability. This is why it's very important. It's very important, but no one's agreed today that this is a law of systems, of anything. It's interesting, but it's a small result. Yeah. And you need to understand that the first generation cybernetics, the cybernetics that was at the end fostered by BCL, the Biological Computing Laboratories under Hein von Foester, almost disappeared because they were totally unable to produce technical results. Yeah. They were funded initially with great amount of money, but nothing came from that. Then this is why the finally in 1976 or 75, what they call in English, they pulled the plug from BCL. Systems biology is a fashion concept today in biology, but system biology is a bunch of reductionist biologists that using, they mimic into deep theoretical thinkers in order to get funded. You know, system biology, the only crucial idea there is give me money, give me big computers, give me a lot of data, and we're going to build you a theory of complex systems and of living systems, by the way. Yeah. Of course, like many other theories, this was created 20 years ago, and the advances has been minimal. People think that ideas from statistical mechanics could be a tool to understand the circular organization of metabolism. And here the big name is Carl Friston, and I want to mention also a Chilean collaborator called Carlos Maureira, who in different ways and with different resources are exploring ideas, fancy ideas for something called stochastic mechanics to understand the stability, at least the stability of metabolism and cognition. And people claims that computer simulation and artificial intelligence could be the solution. But really, brute force attack looking for very subtle and hidden regularity in massive amounts of data, this is not real understanding. I don't know which is your viewpoint of that, but I am sure that most of you will agree with me that this could be helpful, but it's not elegant and doesn't produce real understanding. Fu. Yeah. Also, I want to point out, and this is what we have been doing in the lab, is that we discovered that this guy, Robert Rosen, produced in 1958, 10 years, 11 years before the BCL report number 9, he produced a series of papers extremely difficult to understand, where he talked about the concept of self-fabrication. And he talked about the concept, he did talk about self-fabrication using a mathematical theory called the theory of category that is extremely abstract, and nobody understood him. And believe me, I would love to explain you the concepts of Robert Rosen, but it's impossible to explain them in less than 6 hours of really hard work. Yeah, but this is a person, and I apologize. Sometimes my video froze. Hello, I need to. Excuse me. Excuse me, I need to.
No problem, just take your time.
I am returning here. You know, I have an old computer and the video stops sometimes. I need to reset something. But at least, are you following me? It's not too strange. Yeah? If you have any doubt. Yeah?
Getting very interesting.
Very interesting. Yeah. Then I promised in another occasion to explain to you if you find me a time, to explain you the work of Robert Rosen, but to explain the work of Robert Rosen, you need at least 6 hours of heavy work. You know, Robert Rosen was a very intelligent person, but he wrote for himself. And this is something that you need to reflect, how a very brilliant scientist was able to auto-sabotage himself in such an amazing way. That he wrote for himself. Nobody understood Rosen until we decided here in the lab to explain Rosen to the planet, and it took us 3 years of hard work to understand him, and then 2 years to have the paper published. You need to understand, you know, it's a long story, but no one wanted to publish a paper about Rosen and autopoiesis. Essentially, the concepts of Rosen's and the concept of autopoiesis are very similar. And it's important to have this in mind. Now we are going to return to my presentation. Then this is a book that you need to understand very well. You know, you need to read the book of Rosen called Life Itself. It's what I call here in the lab a psychotic and lysergic book. You know, it's in a totally different realm of reality, extremely powerful. And there you have the circularity of metabolism is explained a la manière de Rosen, you know, Rosen way, that is not an explanation at all, but is very suggestive. And also taking this into account, you can develop something that we have done with Soto and Andrade, what we call this Ouroboros equation, that is equation where you have a mathematical object that is very complex object that can act on itself and produce a result that is itself. Yeah, and these mathematical objects, of course, are categories. Then here, if you want really to involve yourself in heavy mathematics, you should read Rosen and then come to us, because we maintain a very active line of research on category theory. Yeah. Yeah. And we did this, in 2006, this paper where we explained to the universe the cryptic text of Robert Rosen. And this was a big step for us, because in doing that, we also explain autopoiesis. Because you must remember also, you must know that until the year 2000, when I published a book, when I published a paper in the Journal of Theoretical Biology, that journal didn't want to publish anything related with autopoiesis because it was thought that it was too theoretical, too philosophical. Yeah. Then do you follow me? Are you, yeah? Are you following me, more or less? Yeah, good.
Yes, please go on.
Go on. Then now I'm going to go to the second part of the talk, that is structural coupling. Yeah? Also, I need to point out, don't want to, that autopoiesis, if you Google the word autopoiesis, you have 1 million documents in the web, and you have something from everything, you know. Did you know that the Battle of Mogadishu can have an autopoietic interpretation? For me, it was a big surprise. Or that Pokemon Go can be understood in terms of autopoiesis. Or that autopoietic is the missing founding stone to understand economics. Well, you have a lot of papers in big different fields, you know, economics, architecture, the war, and also law. Nicholas Luhmann, you know, was very famous because he has this idea of autopoietic law. And many of these applications are rather dangerous because they think that the theory autopoietic theory applies to social systems because you have like a hierarchy of autopoietic entities, you know. Cells, single cells are autopoietic entities. Human beings, you know, the organism that are collection of cells are autopoietic organisms. And then societies are also autopoietic entities. Then you can apply, you can like translate the ideas of autopoietic metabolism to societies. And then these are metaphors that we think are most of the time misplaced, but because people who use this metaphor, they do not understand the next concept that we are using is the concept of structural coupling. Yeah, and because this concept is so important, I'm going to stop here 1 second. Yeah, do you see me? Yeah. Then in the first part of the talk, I gave an overview of what we will call here in this lab autopoietic theory. That is a theory to understand circular organization of metabolism and to explain its many properties. Essential, and the main property that we want to understand is the stability of metabolism, yeah? And the resilience of metabolism. And this has not been explained. And it's not a question of DNA, nothing. Nobody knows why living systems are amazingly stable. You agree with me? This is it. And we think here that we have some venues of attack to the problems. And these venues are category theory, algebraic view of metabolism, like what you will find in indicational calculus, and some elements of the statistical physics, what is called stochastic mechanics. Yeah. But we claim that the fundamental result to understand living system is the second part of the talk, is a structural coupling. Okay? And now you pay attention. Full. Yeah. Now I'm going to go to structural coupling, and I'm going to respond to someone just asked about niche construction. I have the cartoon to explain you niche construction. Then the first thing to understand is that living systems, they don't exist in isolation. They can only be understood in relation to their surroundings. Yeah, this is the important. And also using autopoietic nomenclature here, we distinguish in all the processes in an autopoietic system, we distinguish two fundamental elements, the organization and the organization is the subset of processes of an autopoietic network that must remain invariant in order to maintain systemic identity. Yeah? And a structure is the collection of processes and components of the network that can change without affecting the systemic identity of the organism. Yeah? This is not the normal usage of the word structures and organization, by the way. Yeah? But then a living system is not only a metabolism, but it's a metabolism with sensory elements and motor elements or effector elements, because a living system is a system that acts upon its medium. Yeah? Then a living system is always in this loop: action, perception, action, perception, action, perception, and the perception generates, the perception is triggered by the interaction with the sensory elements, and the product of this interaction is the production inside the metabolism of a big family of signals that reflect, not perfectly, reflect the interaction of the organism with its medium. And these signals trigger changes in metabolism and trigger the future motor action. And here is the fundamental idea, and here I get to respond to niche construction, the fundamental idea of structural coupling version 1. In the version, in this version, you have at the left, you have the organism that is in a relation, the organism, this organism is in a relation with its medium, but if the relation is continuous and recurrent, you have a deformation, you have a change, a congruent change in the medium and in the organism, but not in the organization, not in the organization, in the structure of the organism. And after a while, you find that the organism and the medium, they have like changed together. And this complementary change and this complementary behavior of the organism and the medium, you are going to call it an object. Yeah. And then the real definition of a living system is not that the living system is an autopoietic system, but the living system is an autopoietic system in its circumstances of a structural coupling. Yeah. Here you have a better description, because which is the better description in the sense that in the previous slide, in this slide, you have the idea, I give the incorrect idea that the medium pre-exists to the encounter with the organism, in the sense that this part here and here, they pre-exist to the interaction with the organism. No, they don't. What we are claiming is, this is why in this new cartoon, you have the interaction between the organism and the medium initially is in a gray area that nothing is defined. But if you have recurrent and recursive interactions, you begin to define something in the organism and in the medium, and at the end, you have created an object. Full. Yeah, you have created an object. And unfortunately for the observer, here you have an observer that is trying to do science about that. The observer only observe the final situation, and the observer then think erroneously with error. He thinks incorrectly that the organism has adapted to an external object, not knowing that what has happened is that the co-creation of an object between the organism and its medium by the mechanism of structural coupling. Then every object is a relational entity that is co-created by the living system. Yeah. Then this is the idea of structural coupling, and this idea is not fundamentally new. In biology, it was expressed 3 times in the 20th century. The first time with the concept of Umwelt by von Wexkull in 1920. The second time by the idea of affordance by Gibson in the 1960s. And the third time by the concept of structural coupling in action in 1970, in the 70s. In fact, in the 80s, this concept is not developed in the book, for example, The Máquinas y Seres Vivos, our autopoietic system, is not developed there. It's developed later in many different documents. Yeah. Then this is a fundamental idea that is not clear yet. Fortunately, now we can put some aspect of the mechanism of structural coupling can accept a deeper analysis. And the deeper analysis is to understand that first, living systems are intrinsically random devices, and that in the interaction between the medium and the organism, here in this interaction, you have these internal signals. And then these internal signals interact with the organization and the structure, and this interaction can be represented by what is called as a Bayesian network. And essentially, the organism uses the new state of this network to decide which action to implement, because an organism can only implement one action at a time. You have a repertoire of many actions, but you need to select one. And then this is the problem of the organism, is which action to select. This is why the problem of the organism is the problem of action. And then essentially, you can see now, remember, a living system, here the question, a living system then is an autopoietic system acting in its envelope of structural coupling or an action. Yeah. Now I have added to the definition with the word acting. Yeah. Then this is how you need to see the living system, as this mechanism linking perception to action through a random, a Bayesian random network. And the fundamental aspect here is that you have a matrix of probabilities, where the fundamental probability is what is the probability, and here I'm going to write, excuse me, which is the probability that I have to implement action, a given action, given the fact that I see the signals alpha. This is the fundamental problem of living systems. I don't look outside, only I look inside myself, and inside myself I see signals of the family, of the alpha family. And the question is, if I see the signals of the alpha family, these alpha signals, should I implement action 1, action 2, action 3? Every one of these questions has a probability, and the organism need to use this probability in order to decide how to act. And then the organism will change in every action you change this probability matrix, and this is learning. Then currently, we are working in exactly these ideas. We're working in these ideas to have a version of structural coupling using this idea of plasticity of this conditional probability matrix, but with a twist where the objects do not pre-exist. The objects are built by the interact confrontation of the organism and the medium. This is what we are doing now. Now, I have a question for you. Are you ready for the question? Who can give me a foo, please? Mickey Lichtenstein, he's giving me a foo. Who can give me a foo? And Juan Manuel Singunetti gives me a foo. Who can give me a foo yet? Rocio Martinez Vivot, unfortunately I see only one, and Nicolas Pellegrin, only see one screen at a time. Yeah, wow. Do you agree then? First, please, Mickey Lichtenstein, can you give me a foo again, please? Fine. Do you agree that? No, this is a foo. And Alejandra Vega is giving me a foo. Amazing. Yeah, good. Who else can give me a foo, please? In the next screen, yeah? Nobody can give, you know? Jose Donoso is making me a foo. Wow. Yeah? And Miguel Sepúlveda is also performing a foo. Yeah? Then you agree with me, because we have this mechanism of language that has a lot to do about mimicking initially. More or less everyone agrees what is foo. Yeah? I'm not going to do now. I am never going to repeat foo in this. I am not going to perform a foo in this class. Yeah. But you agree with me that then Mickey Lichtenstein did perform a foo. Please, can I ask you again, Mickey Lichtenstein, to perform a foo for me? Excellent. Yeah, excellent. Then now I need to ask you to perform a new action that is going to be defined now. This action is going to be called a fa, and a fa is a foo followed by the following movement. Wow, who can make a fa? Wow, Mickey Lichtenstein and Juan Manuel Singunetti are producing fas. And myself, I have never produced a fa in my work, in my universe, you see? Then I can ask, because you see you have more cooperation, then I can ask Juan Manuel Singunetti. How you pronounce your name? Juan Manuel
Cincunegui.
Cincunelli. Juan Manuel, can you perform a fa, please? Perfect. Yeah, this is a perfect fa. Then I can have a verb. I can invent a verb that said, I selected the verb, I selected the word especially for this. Yeah. Then tomorrow, can you look. Can we wait 30 seconds? I don't know how you read the concept. Can you produce a fa? Wait 30 seconds from now and produce a fa. Wait 30 seconds and produce a fa. We're counting. Have 20 seconds. He's very impatient. He has this. Juan Manuel didn't wait 30 seconds, but he produced a delayed fa. You understand? A delayed fa. Perfect. Then we can invent a verb, yeah? And the verb will be to fa. Yeah, to fa. Every verb in English is to learn, to read, to drink. Then this verb is an irregular verb, is to fa. Then I can ask, by example, Alejandra Vega, please, can we to fa immediately, you and me? We are to foing, not to fying. We are to fying, Alejandra Vega and me, we are to fying, yeah, and we enjoy ourselves the act of to fying. I don't know, it's an awful selection of words in English. Yeah? I didn't know because I do this in Spanish. Then you agree with me that it's a lot of fun to do a fa, yeah, a fa. The verb fa produce a lot of fun because if I ask someone, I can order someone and say, Mickey Lichtenstein, give me a fa, please. No, it's not a fa. Mickey Lichtenstein, no, exactly. You see, and someone, because Mickey Lichtenstein said, give me a fa, and he did this movement, and he said, no, this is not a fa. I say, it's exactly. A fa is this movement followed by this movement. Yeah. Then the first reflection that I'm going to give, that I want to do now, is that essentially I have created an object because I can manipulate it like an object. I can tell to you, wait 10 seconds and perform a fa, and you will do it. Yeah. Also, if someone makes an error, produces only this movement, you say, no, this is not a valid fa. Yeah. And we can have an association of fa players, because now I can do the next sentence. When the pandemic is going to be really finished, shall we meet in Chile to do fa in the mountains near Santiago? And every one of you will agree what is the meaning of this sentence. Yeah. Then now the concept of fa is encapsulated like an object. It's so much that I can point to every one of you to perform the object, to construct the object, and you, with your behavior, you produce the object. And we can have association, we have a competition, who makes the most beautiful fa. We can divide the group, the class, in two, and some people make fa, and we can have a team of judges who decide who has the most style in producing fas. Yeah? And we can have rules about fas. What is acceptable? We can have rules, bylaws about fa productions. Then this is essentially, and then we have created a relational object that you will never forget. Yeah? And then every object is like that in our universe. Someone has a question. Chris, you have a question?
Yeah, I was wondering, so this works with someone else in this way, where we create this conceptual object. How do you see it if we're just doing it with ourselves, like in the process of, generating new thoughts? Do you think it's a qualitatively different process? I mean, we can create concepts in the same sense in our internal dialogue, but is it qualitatively different in the external dialogue in your demonstration just now?
No, it's different, but similar in this sense. Is for that, what is at the end, what is an object? So we said an object, from this viewpoint of the theory, is the total collection of behaviors that I can have with respect to this object. Yeah. Then every object is defined by the behaviors that I can have with respect to them. This is a pen, but then some behaviors are allowed by the pen, but others not. Then a pen is the collections of objects that I can have with respect to that object, yeah, first. Then the other thing is that you in every moment, in every moment you need to decide which actions you are going to perform in the next 2 minutes. For example, now you need to decide, I'm going to continue to hear this nonsense about object creation, or I should go and prepare myself a cup of coffee. And you need to decide. Yeah? Then the mechanism that you have here of decision, of action decision, is like a conversation that you have with yourself. And there you can have the creation of new objects there. Yeah? But they are also relational objects. Yeah? But my point is that like objects are all relationals. The exercise that I just did, that I have never done it before, then if it didn't work well, I apologize. This is totally new for me. It depends on crucial. See?
Sorry to interrupt. I wanted to ask, seeing also the questions that are emerging in our chat,
if you,
yes, if you could make a variety of examples of structural coupling in co-creation of objects, from the most simple, most basic ones to these ones you're treating, because I have the impression that it's not clear for everybody what is the structural coupling without more basic examples. Like, for example, I read, how does this relate to objects such as a tree that I perceive outside my window? And this question was related to a more general question of making examples before. So if you could start with reproposing examples that are more basic and arriving here.
Yeah, well, it's a little more. First, I want everyone needs to agree what happened with the production of Fa. We have produced a behavior that can be encapsulated, and the most important thing, treated as an object, because I can give the order perform a Fa, or tomorrow we are going to get together to produce Fas. Yeah, they can be treated like an object. A tree, a tree. You need to know that the nervous system is very funny, because the nervous system is a plastic machinery of extreme capabilities, with extreme capabilities. And we know since early 60s, by example, that if you are not, the classic experiment, you have a classic experiments with kittens, and it's called the held experiments with kittens. I will write it in the chat. Held in 1963. You can check held and kitten. Yeah? If you Google, you have kittens that are raised in total darkness, but for 1 hour a day, you have 2 groups of kittens from the same litter, and one kitten pushes the other, like in a certain type of carousel, in a carriage. Then you have kittens that have sensory motor coordinations that are like play the role of the horse, and kittens that are passengers. They don't have sensory motor coordination. They only see, but they don't move for 1 hour a day, because for the other 23 hours of the day, they are along with the mother in a dark enclosure. It happened that after you play with the kittens, quite a while.
It's 15 hours.
With great surprise, you're going to find that the kittens that were like the horses, the kitten in the sense that they had visual motor coordinations, they are normal kittens. But the other ones are initially blind. They don't see objects because they have never had the coordination of playing with the object. Then the tree, you need to learn to distinguish that this is a tree, because initially, if you don't play with the tree and if you don't have the coordination of the third dimension, the tree in your retina is going to be a blob, and you don't know that this is a tree. You make this a tree because you play with the object crucially, you play with the third dimension. If you don't have the third dimension, you are not going to distinguish objects. This is fundamental. Then again, has to do with playing with touching the object. And if you read the book, Sachs, the A Neurologist of Mars or A Stranger or Much, I don't remember the name of the book. There they describe this amazing case of people who were born blind and somehow they recuperate the sight very late in life, and these people were unable to discover that this object and this object were the same objects. Because for us, we need to learn that the rotation of the object doesn't change the nature of the object. But in those cases, for them, the rotation of the objects, because the rotation of the object produces very different retinal images, for them, they were different objects until they touch it. These people were blind for 20 years. Then when they touch it, I know which is this object, which is this object. Then, you understand, because we have this intuitive way of thinking that we think that a tree in front of us is an object that by itself it appears in the world, but it's not. It's an active action of creation of your brain. And this active act of creation is mostly due to the fact that we manipulate the third dimension, that we manipulate objects. If we don't manipulate the objects will not appear like that they appear to us. Yeah. Then a tree is also an object that you learn to manipulate. It's a relational object in 3D space.
Murillo, is it clear now? Or do you have further questions? More clear.
It's not really clear.
Not?
So if I could suggest something, if I have the impression that when it seems uncontroversial to define to say that a bacteria or another single cell is an autopoietic system, it becomes a bit more complicated, perhaps to say if a multi-celled organism is an autopoietic system or not. It's a bit less clear to me that. But if we could stay in the simple case of a bacteria, for example, could you maybe give a concrete example of what you mean by structural coupling in E. coli in interaction with its environment, or maybe an amoeba in its environment, for example?
Look,
and in what sense would an object appear there as well? What would it mean for an object to appear in that case?
Look, this has been a study and it's called bacterial cognition in the sense, but this is the basic behavior. Let me see if I can use my tablet. You know, I am bringing here high technology. Wait. Only the host can share in this meeting. Can you give me authorization to share? Can you give me authorization to share, please? Who is the host here?
Yes, I'm going to do that.
Yeah, to my iPad.
It's done.
It's done, yeah, thank you. Yeah. Then bacteria, here you have Escherichia coli has two flagella. When the two flagella, they move at the same beat, the bacteria moves forward. But if the two flagella, one move in one direction and one in the other phase, the bacteria tumble. Then the bacteria has only two possibilities of moving, forward or tumbling. Yeah. And the bacteria tumbles when you have an extra amount of calcium inside. You have too much calcium that is a poison. It's very necessary for metabolism, but free calcium is a fucking, excuse me the language, is a fucking pulse, is a fucking poison for metabolism. Yeah? Excess calcium produces the tumbling of the bacteria. Then here you have a happy bacteria that is going forward, and here you have a wall. Then the bacteria goes, the bacteria touches the, and has a shock, an interaction, then the bacteria returns there, and because it's a bacteria without emotions, the bacteria continues tumbling in that direction, and the bacteria will again hit the wall. Yeah, and then the bacteria will tumble. Will hit the wall. Will go back and we'll do it one more time, and then this is the third shock. You know, the third encounter. This is more or less the third encounter of the bacteria with the wall. But at that moment, something amazing happened, that the bacteria, instead of continuing this behavior forever, the bacteria tumbles and rotates in any random direction. And because it rotates in any random direction, the next movement of the bacteria is going in this direction, then she's escaping the wall. She's going in another direction. And then all this behavior is a behavior that defines an object, what's it called, an impassable barrier, and the bacteria has invented a procedure to get rid of this impassable barrier by tumbling. Then in this sense, this shows that the bacteria has coherent behavior with respect its circumstances. Yeah, and then the object here is the object is an impassable barrier that can be overcome. I don't know how the bacteria will describe it. And the trick, by the way, is that in every, how it does this, in every shock, you have a small amount of calcium that go inside, in every shock. Then after 3 or 4 shocks, you have enough calcium inside to trigger the tumbling mechanism. Then there you have clearly, a notion of object creation through behavior. And people has interpreted, I didn't discover anything, any of this. People has interpreted this behavior as bacterial cognition. And you can in fact Google. Yeah. And I think some scientists from Australia, Pamela Lyon, in fact talked about this phenomenon as an structural coupling. Then the bacteria did create an object by its behavior.
Can I ask something?
See, please.
I feel that there is a distinction that is missing in this story, because what you're calling the wall in your drawings was already there before the bacteria reached it. So there's this distinction that I think is missing, that there is, I suppose what I'm calling is, are you a realist or not? Is the wall there before the bacteria touches it? We may not want to call it an impossible barrier, because an impossible barrier, it's impossible for the bacteria, but the wall is there. right? And I'm applying the label of the wall because that's how I relate to it. But there's something there that is there even before the bacteria reaches it. And when the wall becomes meaningful for the bacteria, then it becomes an object for the bacteria to which we might want to use a different label. Now it's a barrier for the bacteria, but the material structure, if that's one maybe neutral way of describing it, was already there.
I agree. I apologize because I was kind of like from my viewpoint, because other experiments, they show that the bacteria, what is the relevant thing is the tumbling, the bacteria tumbles. Then for the bacteria, other situations are equivalent. The bacteria must have a very different word. Every situation that produces an increase in calcium produces this tumbling. Then the bacteria, in fact, has a lot of situations different situations that for the bacteria will be like impassable barrier that are not only a wall, but are also changes in pH, anything that induces the sudden increasing in the concentration of calcium. For the bacteria, they are treated equally. The bacteria tumbles.
But let me ask you a direct question.
The object that I incorrectly describe as an impossible barrier, from the point of view of the bacteria, is a very sophisticated object that contains barriers, pH-D gradients, and other molecules. All of them are treated in the same way. Then in this sense, really a new object, from my perspective, is created.
This perspective, Murillo, is essential to the theory. The structural coupling exists in the point of view of an observer that can observe the interaction between the system and its environment, which is what Juan Carlos is describing as an observer, as from his point of view.
The bacteria, every time that the bacteria finds a situation, something that will induce internal calcium, it generates tumbling. Then for the bacteria, all these situations are similar, and for the bacteria will give a similar description of the situation, of what happened. Then I incorrectly, only because I use the word wall, but it's not only a wall, it's every situation that increases calcium produces this tumbling. And the net effect is that the bacteria changes courses and escape from that situation. Remember that the fundamental problem of a living system, here we have a living system. The fundamental problem of the living system is to advance or to retreat.
Lete, we're not seeing your iPad anymore.
Well, the fundamental, excuse me. Technology. Rocio Martinez, I will try to solve it. Rocio Martinez, please.
Yes, hi. I was wondering, this example that you were giving about the bacteria and the wall and structural coupling, with the cartoons, as you said, that you have a time 0, time 1 when there's a perturbation, and then you have an object that's, let's say, co-created. If there's calcium release because it hit too many times the wall, then the bacteria turns. But if it's structural coupling, shouldn't the wall have also an upset thing, like the drawing that has this kind of wave? So it's that's not in this example, isn't it?
No, in this example, this example, this example is not. But from our perspective, from the perspective of human, that we have this amazing plastic machinery called the brain, the nervous system, that has highly plastic. Our interactions are really our meaningful interactions are always with our humans, and in this interaction with our humans, we change each other symmetrically all the time. In the case of the bacteria, it's more difficult, but give me a little more time, and I will have the explanation. Mind you that the soil, the initial, if you have, I don't have I need to have my My iPad. Yeah. Look, then this is the drawings that I was making before. You know, for a bacteria, all the situations that increase the amount of calcium inside, they induce tumbling. Then for the bacteria, all these situations must be treated more or less, I would say, as the same object. Then here you have really, it's not a, in this sense, the object is a multidimensional object that is not the same to the object that I perceive. Yeah. For the bacteria, the wall and a portion of the water that has high pH are more or less the same. Yeah. This is one point. And then the fundamental problem of a bacteria of any living system is to advance or to retreat. This is avanzar or retroceder. This is the fundamental problem, that because it's a problem of action. Yeah. And then the soil. Look, the soil, how it's made initially is, you know, the first soil is if you have a fungus who's an algae, and here this, I think this is, they create a symbiosis, and the next effect of this is that they, little by little, they change the stone, and here you have the first production of soil in the surface in this planet. You know, that is these two living systems, they live on top of a stone, and they transform the stone, and the stone will be fundamental for the other living systems. Then I will say that if you think hard, you are going to discover that the physical medium is also changed by the interaction of the bacteria. Then I'm sure you can find it.
I think that Murillo has another question.
Yeah. Murillo, which is the other question?
Yeah, just quickly. So if this is, I've read this example of the bacteria in different books before. So if this is an easy or simple example, or as simple as it gets, could you maybe go, if I'm looking at the from your slides, the slide with the representation called a better depiction of structural coupling, right?
Yes.
And I'm trying to make sense of the story you told of the bacteria moving and tumbling, and I'm trying to make sense of it in terms of the representation of a structural coupling that you gave, and I can't make sense of it. I wonder if you could help, because this image of, well, the representation itself that is used to illustrate the notion of structural coupling. Can you maybe tell the story of the bacteria and tell me how that is represented in the diagram?
Yeah. Oh, this is difficult. This class is going to be difficult. You are mentioning this
No
slide?
No, it's before that. It's one that it's called a better depiction of structural coupling. That one, this one, yeah.
Yeah. Let me try. Yeah? Changing from Zeus. Wow, everything in your screen. Can you, what are you seeing? You're not seeing my screen, no.
We see a slide.
See live, something stop. Cancel. Let me, wait a second. I have here is 1521. Can you give me 5 minutes to solve a little computational problem? Hello? Leave.
Uza, can we have a break then that we
Yes.
use?
See, can we have a break? Because I have some fundamental, something is happening to my system.
Okay, so maybe we can make a 5 minutes break.
5-minute break, yeah?
Thank you. For everybody, a coffee break.
Yeah. Then we will return in 5 minutes, yeah?
Perfect. So 7:26.
Yes.
Thank you. I think we are back. Juan Carlos, can you hear us?
Yes, do you hear me?
Yes.
Yeah. Then when everyone is back, we can continue.
Okay, I think maybe wait another minute, but
I think we can continue.
yeah. Please, I think we can restart.
Yeah, perfect. Then now someone asked me how to, I don't want to change the screen because then my system gets totally messed up, yeah? But someone asked me how to have this cartoon excuse me, for the case of the bacterium, yeah? You agree with me? This is some I was asked. Then I'm going to try. First, we need to understand that bacteria are in some sense special. First, a bacteria lives 20 minutes, and and then what you need to consider that for bacteria, these circles are not the bacteria themselves, but the lineage of the bacteria. Yeah, because the bacteria reproduce so quickly, and it's that what really matters is what happened with the lineage. This is a technical aspect, but you need to have it in mind. Yeah? Then a bacteria, initially, here you have a bacteria, and I'm drawing the bacteria, and in front of her, the bacteria has an unknown situation. Yeah. Then, initially in this encounter, in these encounters that are fatal for the bacteria because or the bacteria will continue forever hitting the wall, or the bacteria will go into a portion of the space with high pH that are fatal for the bacteria. Then, because the bacteria has to act, and the internal mechanism, the net effect of will be that some bacteria, this is because the creation of the object for a bacteria can only be understood in the term of a lineage. It's a property of evolution. Yeah? It's a property of the lineage, not of the single bacteria. A single bacteria in its lifetime cannot make enough changes to account into this. Then, but the bacteria encounter a wall, and then little by little, the lineage of this bacteria, and when it encounters this situation, begins to accept calcium. Yeah. And because the acceptance of calcium and the effect that calcium has on the motor also changes. Yeah. Then the bacteria, here you have the motor part, and here you have the entry of calcium. This is the sensory part. Then the lineage is not the bacteria. For the case of a bacteria, it's impossible. The lineage of the bacteria changes, and you have a different motor and a different mechanism of the entry of calcium. Then, after a long life of interaction between the lineages of the bacteria and what myself as an external object, I will call this as external observer. I will say these are walls, section of high pH. Yeah. Then at the end, because Darwinian evolution, then you have the behavior that the bacteria, when the bacteria encounter these places, then you have the entry of calcium, who has the net effect of changing the behavior of the flagellum, and the bacteria tumbles. Then, in doing that, the bacteria has created a relational object. The bacteria knows this is a space that I should avoid. Then it has created an object that is defined by her behavior. In fact, when the bacteria begins to encounter the object described from the observer, the bacteria tumbles. At the end, after a little interaction, the bacteria tumbles. Then the bacteria has changed, in the sense the initial bacteria here in this situation, at T0, the bacteria didn't have the behavior, but little by little, its lineage, not the bacteria itself, the bacteria are in this sense special because they are not plastic devices by themselves, but the lineage is very plastic. Yeah, you have that the bacteria has created then has created the notion of the space that the bacteria should not go into. And this is a complex space. It's not only for walls, but also for pH. Then you understand, for the bacteria, walls and pHs are similar objects.
Juan Carlos, we have an explosion of questions. So I start maybe with Jose.
Please.
Yes, so I would like to go back to the, I mean, it's related to what we're talking about. I would like to go back to what Rocio pointed out, that in the example you gave, the environment doesn't change, right? But you can see it from the perspective of the bacteria, of the bacterium, when the fact that it moves away from whatever it is, be it a wall or some toxic environment or whatever, the fact that the bacteria is moving away, for the bacteria, the environment is actually changing, right? So there is, from the perspective of the observer, the bacteria moves, but from the perspective of the bacteria, the environment actually changed. The bacteria itself, the bacterium, sorry, doesn't know that it moved. Is that correct? So in that case, yes, we would have a structural coupling in a sense, right?
In a sense, because your confrontation, I will call the confrontation, here you have the environment. I will put it as a wall. I agree with you that, look, you know, I will put it like, excuse me. Here you have a living system that escaped this environment, you know, and tumbling, because then the change, in the sense, is the impact, you know, how you project into the space changes. Then I agree with you that I don't need this environment to change, but what needs to change is how my interaction with the environment changes. Then in this sense, I am producing a de facto change in the environment. I agree with you. But wait. But in most of these cases, the environment change long term. The environment will change. You know, the bacteria, they have a collective behavior called quorum sensing, and this will change the environment where they live. Yeah. Then it's difficult to see the change in environment in many cases, but my postulate is that you will have a change, what an external observer will describe as a physical change in the environment for living systems.
Gabor?
Yes, it's very, very interesting. Over the weekend, I was doing some cleaning around the house and observed structural coupling, exactly how Juan Carlos is explaining now. A gravel bed was made around the house for drainage purposes and to prevent weeds from settling. However, some seeds were carried by the wind among the pebbles, and the dust also settled among them. And the seed took root in the little dust and began to incorporate the earth into its own organism. And it grew quite strong after a while, after a few weeks. So when I didn't like the weed and went to pull it out, not only did the weed come out with its clean root system, but the entire layer of soil around it. So the dusty environment became part of the weeds, and was transformed from simple grains of dust into a unified, structurally coupled earth root structure. So the way to remove the soil in order not to feed any additional seed was to pull out the weedy soil along with the weeds. But I didn't know that it was the case. So I just learned by doing it that I didn't pull out the weed, I pulled out the structurally coupled earth root structure or weed environment structure, and not the dust anymore.
But myself, I'm open that in general, living systems, living system first, for human, here you are as a human, and here you have other human, and if you are in an interaction between both of them, they will change congruently. For the interaction between humans, it's easy to see how a change in one is a change in the other two, because we have this huge plasticity. The problem, but for almost all other living systems, we live inside other living systems, the soil. In fact, look, the soil, here you have a tree, the tree lives on soil. And the soil is the transformation of all the history of living systems before. Then we are continuously changing the environment where we participate in a very multifaceted pathways. Yeah. The case of the bacteria is not obvious, but I will claim that at the end, also the bacteria changes the environment. And it changes in the following. By example, in the history of humanity, look, initially you didn't have any in the planet Earth, in the atmosphere, this is the planet, you didn't have oxygen. Oxygen was not present. And oxygen, only the 100% of the oxygen in the atmosphere is the product of bacteria, of photosynthetic bacteria that began to act like 2,300 million years ago. And the effect that this has, that because of this huge amount of oxygen, then the Earth went into a deep glaciation. Then the living systems do have an amazing impact in the environment. The environment changes because of the metabolic behavior of bacteria all the time. And the proof is that we have oxygen now. Oxygen was not a part of the atmosphere. Oxygen is a part of living, is the end product of living system physiology. Then myself, I will stick to the basic diagram, is that the interaction is dual. The object that is created in both places. Sometimes it's not easy to see for the bacteria, but for humans, it's obviously to see. This is obvious that the change is mutual. Yeah? And that the coupling is based on actions. This is the important aspect. Yeah? It's action that triggers the structural coupling.
Georgina?
See?
Georgina, do you have already an answer to your question, or you would like to deepen this aspect?
Yes, well, maybe could you help me just to see like the diagram, but with an interaction with both living systems, please?
Yeah, like this one.
Yes, that is one.
Yes.
So what would be the difference between only having a living system with the environment as you draw in, well, in the other image in your presentation, that the medium or the environment is just like a curved line, but what would happen when you have another living system?
It's because the living systems, in order to maintain the autopoietic, the interesting is, in order to maintain the autopoietic organization, in order to maintain the core, living systems have a huge amount of processes of regulatory process, and the net effect of this is they are plastic devices. They are changed. Living system cannot be hardwired. They are plastic devices. then the amount of plasticity of living system is order of magnitude of the plasticity found in rocks. Then when you have two living systems interacting like this, and they interact like, then one is the medium of the other, then immediately they begin to have interactions between them, and they change, they co-change, between you and your dog. Fuck, immediately. This is the result of the amazing plastic mechanisms that are the result themselves of the huge amount of regulatory processes that you need to have in order to maintain your self-fabricating metabolism. You understand? We are amazingly plastic devices.
Okay. So
and the brain, excuse me,
yes?
and the brain, the nervous system of vertebrates, not of humans, the nervous system of vertebrates is a machine of plastic changes. And language is a biological function that enables more plasticity with respect to actions, because the role of language is not to transmit information, but to produce coherent behavior between different humans. This is the role of language is not to transmit information, but to produce coherent behavior in some sense. Yeah, and all of these mechanisms are based on the plasticity, inherent plasticity of living systems.
Okay. Thank you.
Yeah.
I think Rocio intervened with many questions just after Georgina. Don't know if she feels that now she had answers or she wants to.
Okay. Doesn't matter. We'll keep on.
We'll keep on, yeah.
I think it wasn't it wasn't the happiest. I understand the idea, but the wall and the bacteria, maybe it's not the best fit, or it's trickier. But I understand the idea. Don't worry.
No, but the symmetrical interaction there.
Claro, could be, but yeah. I want to maintain this. The big advantage of this example is that it has been worked with detail, but many people, this has been studied with detail. The tumbling behavior of bacteria has been described with many decimals. Then now we understand a lot of it, and the crucial role of calcium. This is, yes.
I think there are many people that are interacting in the chat. I don't know if someone
yes, and it seemed to me that this distinction is only made clearly here. And I think that if we do not make the distinction, then that an object is being created is confusing.
The distinction between the environment and the world.
It's the question of the Umwelt of von Uexküll. So it's a question of the perspective of the observer versus the perspective of the organism.
Yeah, well, but I want to insist in the example of the bacteria, because I think that the example of the bacteria is the toy example. I know that, look, the lineage of the bacteria. In the lineage of the bacteria, they have changed in order to accept that some interactions that from the point of view of the observer can be a wall or zones with high pH, they induce the entry of calcium. Then in some sense, the bacteria has learned to relate wall from the point of view of the observer, because this is how I talk about that, the wall and zone of high pH with the entry of calcium. And this entry of calcium has a behavioral effect. Then now the bacteria has an object. The bacteria has created an object that the object of the bacteria, object from the viewpoint of the bacteria will be zones that must be avoided. I think that this is how the bacteria will see the world of the bacteria. Yeah, and the bacteria has a method to avoid that has been created by the lineage of bacteria, and is structurally created in the sense that is due to mechanical properties that impinge on the metabolism. This is due to the entry of calcium. And the circumstance, the entry of calcium triggers all these processes that ends with the desynchronization of the flagella and the tumbling behavior. Yeah. Then I will agree myself, I will maintain that the bacteria has created a very complex object that, from my viewpoint, I will define it zones that the bacteria avoid by its own behavior. Then in this sense, then this is the Umwelt of the bacteria. And myself, I will agree with the comment of Murillo from Denmark, that the suggestion that an object is being created is confusing. Myself, I am a little confused about that, but I maintain that the bacteria does create an object.
So this is okay with regard to the lineage of the bacteria, but also in the single life of a bacterium, the idea is that by self-producing itself and self-regulating its processes of self-production, is continuously creating a meaningful world from a perturbative environment. Every time he associates a kind of perturbation to, even if this derives from his phylogenetic history, every time it's associated a kind of perturbation to a scheme of self-regulation, and so a behavior, is treating a perturbative environment as a meaningful world for him, for itself.
For a club.
We agree on that? Or
yes, because the environment, because the lineage of the bacteria has lived in that medium, little by little, the bacteria has transformed this medium into a niche with properties. And the properties depend on the metabolism of the bacteria and the behaviors triggered by the changes, triggered by the interaction of the bacteria and the medium. In this sense, the object is relational. It depends on the actions triggered by the encounter of the bacteria and the medium.
So in the image, the depiction that someone, I think Murillo or Chris, made you bring up again, the change in the environment is a change for the organism.
It's a change, claro, because they want, this is the diagram that Murillo wants us to explain.
Mm-hmm. So in this diagram, we're in a phenomenological depiction.
Claro, yeah. How this, and then this at the end will end in something like that. Yeah. Then you have a change in the environment. For the bacteria, really, in this moment, for this example, I haven't thought about this well, I'm completely honest, but essentially all living systems will transform the environment in order to live inside the environment.
By, as Luisa says, creating a context of meaning for the organism.
It's because they change the organ, they change because the behavior, first, the behavior, this arrow is not it's not only actions, bacteria, the behavior of a bacteria is movement, the behavior from the point of view of a bacteria is movement, plus the emission of chemicals. And these chemicals do have an effect in the environment. Yeah. Then the bacteria will change the environment not through the movement, but the emission of the chemicals. Then in this sense, the environment will change due to the actions of the bacteria. Yeah.
Yes, there is an interesting discussion in the chat that maybe can be summarized through a comment that I would like to propose to you, Juan Carlos, from Juan Manuel, who say, however, it seems to me that structural coupling does not mean that we should expect an observer to be able to match the mutual transformations of the interaction. What do you think of this?
I agree. So the external observer has no real access to the world created by the living system. You understand? The external observer has his language, and his world is non-commensurable, you know, with the world of the living system under analysis. Then when I talk about the world of the bacteria doesn't see its world. You know, it's a totally different concept. The concepts of the bacteria are totally different from mine. Then in that sense, I am going to make some mistakes. Yeah. Then I agree that the world of the observer cannot match the mutual transformation of the interaction. Yeah.
But
in other words, I will never be able to understand the world of bats. You know, bats, they sense distance with ultrasound, and they have amazing sexual life. You know, bats are really amazing mammals. I will never be able to understand the world of a bat. I will explain in human terms the world of a bat, and I will always be behind.
Yes, but the matching between and what happens into the environment and what happens for the living being is a matching that is done in the perspective of the observer, according to the theory of autopoiesis. Do you agree with that? Or
yeah, because you cannot escape the person who does the explanation. Here you have here you have here you have the organism, and here you have the medium, and here you have the observer. And the observer lives in the world of human with language and with the concept. And one mistake is to think that our concepts here are the concepts here. You know, the concepts, this is something that we teach initially in the course, the concepts of the explanations.
So the structural coupling belong to this.
Are not the concepts of the phenomenon. Yeah. This is the concept of the explanation. I can only explain the world of bats using human ideas, but the human ideas will never encompass the vastly different way that bats must have to understand their own universe. Yeah. Then, but myself, I will maintain that the basic phenomena is a co-design, is a co-change in the organism and the world that contains the organism. And in this co-change, you create the niche of the organism. Yeah.
Great. We have still really 5 minutes. I don't know if there is a last question.
Yeah. Okay. If life mind continuity is true, then it's relevant to neuroscience. Well, this, by the way, then this view, I want to change to close this view of the organism. You know, this view of interaction between living system and the universe is very relevant today because of the concept of transdiscipline. Because many times we have that the big problem of humanities is that you have here a human being, you know, interacting with other human beings with different culture, and they think, you know, that they're talking about the same object, A, but no, the objects are not, we have to use the same language, but because they encompass different coordinations, they are different entities. And I want to close, I want to give an anecdote. Can I close here? I will close this. Let me close. Let me stop the video and start the video again. In 1987, Gorbachev and Reagan met in Reykjavik in Iceland. And the topic of the meeting, this was the time of the big Soviet-US summit, was the total abolition of nuclear weapons in the planet. You like that? And they were at this distance of signing that treaty. And the only problem, it was a disagreement on one word. Who knows which word was which word was it? They agree in everything. They were really ready to sign the treaty, but they couldn't accept. They have a disagreement on one word. Which word was it? Nobody knows the story. It's an amazing word. You will not believe it. I will tell you, laboratory. Why laboratory?
Yes, why?
Why laboratory? Because both parties agreed to the total elimination of nuclear weapons, but that each party could have some weapons in their laboratory. Perfect. Every party can have 10 weapons in their laboratories. Fine, sign. But the problem is what for the Soviets, a laboratory was a building. And for the US, a laboratory was Los Alamos National Laboratory, something that is 5,000 hectares in extension. Then the things that you can do in a building are very different to the things that you can do in 5,000 hectares of land. Then your coordination, your action perception coordination that you can perform are vastly different if they are in a building or if they are in a big extension of land. Because if you are in a big extension of land, then you can hide many things, put a special device to send bombs to the other side of the planet, things that you cannot do in a building. Then the Soviets said, no, wait. For us, a laboratory is a building. And the US said, no, our laboratories are very big. No, you cannot have big laboratories. Why? In fact, they have names. One is called Los Alamos National Laboratory. The other is called Lawrence Livermore National Laboratory. 16 hours. Yeah. And the rest says, see, this is why we don't like you to have bombs in laboratories. Bombs should be in buildings. And they couldn't agree. And why they couldn't agree? Because the motor coordinations that this word, this label implies are totally different, and they create different relational objects. The Soviets were worried that the US will hide bombs in these big extensions, and something that you cannot do if you have only a building.
So thank you very much also for the anecdote that is bringing up, as Amy underlined, a new question, how we define the boundaries of a system, of systems. So, and we will get back to this, we promise, at least in the discussion. And in the final session, which will be dedicated to discussion, we will arrive at, because it was one of the first questions that arose from the very first session. So thank you so much, Juan Carlos, for your generosity in being here with us with two fantastic lectures. Thanks to all the participants for engaging so deeply into the discussion. And so we can close here this session. And we will have the next session on the 23rd of November with Ivan Thompson. So exploring the theory of autonomous systems. So.
Yes, thank you so much, Luisa, and thank you, Juan Carlos. And besides Evan Thompson's talk next time in 2 weeks, we are going to have another great event tomorrow for MLE friends with Professor Antonino Raffona, talking about the neuroscientific and phenomenological insights on different forms of the Buddhist meditation. And we are also going to have a third talk in the new EVA alumni talk series, the European Varela awardees talk series with Josipa Mihic towards the Caring and Mindfulness Schools model on November 24th, the day after Evan's talk in 2 weeks. Hopefully some of you can also attend these events. Thank you so much.
Thank you very much. Bye.